In this video, we're going to look at the expectation of a geometric distribution. So here we've got an example where the probability of success is 1 in 4. Now I want you to think about what you'd expect the expectation to be. If you have a 1 in 4 chance of happening, on average, how many goes will it take you to succeed? Now, the intuition for most people is it would be 4, and that is correct. So that is the answer. Now let's think about why that's true. Now, how did you actually get that answer? Well, 1 in 4 goes, you'd expect 1 success in 4, so I guess it would take 4 goes until I got a success. Well, what you might have done is spotted that if I do 1 divided by a quarter, I get 4. And indeed, that is the formula. The formula for the expectation of a geometric distribution is simply 1 divided by the probability, which in this case was 1 divided by a quarter, and that was 4. Okay, now that we have a formula to use, let's apply it in the context of a question. So we have a geometric distribution with an unknown p. Now, given that the expectation is 2.5, find the probability that x is 3. Well, the expectation is 1 over p, so that's 2.5. So that means that p is, well, I can just do 1 divided by 2.5 and I get 2/5 or 0.4. So what's the probability that x is 3? Well, the probability that x is 3, the first success coming on the third go, involves failing twice. So failure is 0.6, and that had to happen twice, followed by a success. So the first success then occurring. So 0.6 squared times 0.4 is 0.144. Now that's an example of how we can sort of reverse engineer what p is given the expectation. Okay, so that is how to find and use the expectation of a geometric distribution. See you in the next video.